fraction 5.5 bases other than e. I want to go over some property that we did cover in intermediate algebra and pcal. So the first property is say that log base a of y equal to x if and only if a to the x equal to y. So if and only if is mean if you have this, then it's equal to that, or if you have this, it's equal to that. It's go both direction. The second one is say if you have a raised to log base a, remember these two have to be the same, of x is equal to x and x has to be greater than 0. The third property is say log base a of a to the x is equal to x for all x. So let's look at our example here. The first one, I have log base x of 125 equal to 3. I'm going to apply the first property here. I have log x of 25 equal to 3. Then it should equal to x to the third equal to 125. I'm using this property right here. Changing log to exponential. And then I'm going to write my right hand side as exponential. So 125 is equal to 5 to the third. These two are equal and they have the same exponential, so the base must be the same. So x is equal to 5. Alright, let's look at the next one. I have log base 3 of 1 over 81 equal to x. Again, I'm going to use the first property, change log to exponential. So 3 to the x is equal to 1 over 81. I'm going to write 81 as exponential, which is 3 to the fourth. Then because it's on the denominator, I bring it up, so my exponential will be negative. Now they're equal, they have the same base, so exponential must be the same. So x equal to negative 4. Let's look at the next one. I have x squared minus x equal to log base 5 of 25. So what I'm trying to do is I'm going to get rid of log here. So I'm going to apply property number 3. Property number 3 said I have log base a to the x equal to x. So I'm going to write something in an exponential of 5, which is 5 squared. 5 squared is 25. Then I'm applying this property. So the right hand side is equal to 2. Then I just set it equal to 0. Factor the quadratic equation. So x minus 2 equal to 0, which means x equal to 2. Or x plus 1 equal to 0, which means x equal to negative 1. Alright, let's look at the last two for this board. When you have x on the exponential, the idea is you want to bring it down to the base. Alright, you have to bring it down on the base, because there is no way you can write 3 to some power and equal to 75. That doesn't exist. We can't think of it. It's different from the rest, because 125 we can write it as 5 to the cube. We cannot think of anything base 3 and to exponential and go to 75. So when you come across something like that, you're going to take log. You can take log base 10, base e, or any base at all. But most of the calculator have base e, which is ln, or log base 10, which is just log. So I'm going to take log both sides, alright, base e. So it's going to be ln 3 to the 2x equal to ln 75. Alright? And there is a property so that I can bring exponential up front, which is what I want. I want to bring the x down. So I'm going to have 2x ln 3 is equal to ln 75. From here I can solve for x by itself. So x would equal to ln 75 divided by 2 ln 3. From here you can use the calculator. Any scientific calculator should be able to give you ln 75, and then you divide by 2 and divide by ln 3, which is approximately 1.96. Alright, let's look at the next example. This example, the last one here, I can do two ways. I can apply the first property, change it to exponential, the first property here. So if I change it to exponential, I'm going to have 2 to the negative 4 equal to x. So which means I'm just going to rewrite this. X is equal to 1 over 2 to the 4th, which is mean is equal to 1 over 16. That's probably the easiest way. Another way, which is not easier, but I just want to show you because we're going to apply property number 2. Property number 2 is say a raised to log base a of x equal to x. I just want to show you how to do it. So I have log base 2 here. So I'm going to try to apply that. So I'm going to exponentiate both sides e to 2. So I'm going to have 2 log base 2 of x is equal to 2 to the negative 4. I picked 2 because I want to apply property number 2. Then on the left hand side, I'm just going to have x is equal to 2 to the negative 4, which means x is equal to 1 over 2 to the 4th, which is 1 over 16. Which is the same thing. I know it's the same thing, but I just want to show you how to apply the property. Alright, let's see more example. Hi, let's continue our lecture. This is theorem 5.13, derivative for base other than base e. So let a be a positive real number that not equal to 1, and let u be a differentiable function of x. The first one is that if you want to take derivative a is any positive real number here to the x, it's going to equal to ln a to the x. Now let's look at my first example. I have f of x is equal to 4 to the x. So they want you to find derivative. Your a here is 4, which is positive real number and not equal to 1 raised to the x. So it's going to equal to ln 4, which is the a from the theorem, a, which is 4 to the x. So ln 4 to the x. Let's look at the second one. If I want to take derivative of a to the u here is an expression, so not just variable. So it's going to equal to ln a to the u, and the derivative of u. My example here is f of x is equal to 3 to the 2x. 2x here is my u, an expression. So it's going to equal to ln 3 to the 2x, and derivative of 2x is 2. And I rewrite this as 2 ln 3. 3 squared is 9 raised to the x, alright? So that's the example of the second part of the theorem. Now look at the third and the fourth. They about the same, but one is variable, one is an expression. The difference is if you have expression, you have to take derivative of an expression here. So let's look at our example. I have y equal log base 10 of cosine of x. Think of cosine of x as u. So I'm going to use the fourth one here. So it's going to equal to 1 ln 10. My u is cosine of x, so cosine of x. Derivative of cosine of x is negative sine of x. Sine over cosine is tangent, and the negative I just carried here, and on the bottom I have ln 10. Alright? Next one, an integral of a to the u du is equal to 1 over ln a to the u plus c. Again, my u here is an expression. This example, I have 5 to the negative x dx. So my a is 5, my u is negative x. So I let my u equal to negative x. So the u will be negative 1 dx. I'm gonna put in the form of a to the u du. However, my du is negative dx and I only have dx here. So I need -1. So I multiply by -1 inside an integral here and -1 outside. So it's fit this formula. So the -1 here is the same as -1 here. And integral here would be 1 over ln 5 to the negative x plus c. Let's look at the last example. I have an integral of x 5 to the negative x squared dx. This is my a, alright, this is my a. So my u will be negative x squared. My u will be negative x squared. So du will be negative 2x dx. I don't have my du here. I have x dx. So if I have -2 dx, -2x dx, I will have my du. So I'm gonna put -2 here. So I will have a to the u du. So I put 1/2 in the front. Now when I take an integral, the 1/2 here is coming down and this is just a to the u du, which is 1 over ln 5 to the negative x squared plus c. Alright, we finished 5.5. I'll see you again later. Bye.